Welcome to The Explainer. Today we're doing more than just talking about code. We're actually going to build something, a decision toolkit for you, the modern software engineer. We're going to tackle those critical choices you've got to make like every single day. All right, so let's just jump right in. What are the big questions we're talking about? Things like, should I use a load balancer or an API gateway? How are my services going to talk to each other? And how in the world do I manage user identity securely? We're taking some awesome insights from the ByteByteGo newsletter and turning them into a super practical guide for these exact choices.
All right, first things first, let's start right at the front door of your system. We're going to look at the two key players that stand between all your users and your backend servers, the ones that handle every single request that comes in.
Okay, so first up, the load balancer. The easiest way to think about this, it's like a traffic cop for your servers. Seriously, its one job is to take all that incoming traffic and spread it out evenly across all your different server instances. This way, no single server gets totally slammed. Plus, it's always doing health checks and, handling failover if one of those servers decides to take a nap.
And then you've got the API gateway. Now this is way more than just a traffic cop. Think of it more like a combination of a bouncer at a club and a really smart concierge. It's handling all the complex stuff like rate limiting to stop bad actors, authentication to check who's who, and even API aggregation to make life easier for your clients.
And this is where it really clicks. This slide just lays it all out so clearly, right? You can see they're totally different jobs. The load balancer, that's all about the network level, just pure traffic distribution. The API gateway, though, that's playing on the application level. It's all about control, security, and management. So here's the most important takeaway, the thing you have to remember. You don't choose one or the other. It's not a competition. In pretty much any real-world production system, they're a team. The API gateway sits out front doing the smart stuff, authentication, routing, and then behind it, a load balancer takes that clean, validated traffic and distributes it to the right services. Okay, so the traffic is safely inside our system. Now what? Well, now we have to figure out how our microservices actually talk to each other. Let's dig into the two main ways this happens. First up, you've got REST. And look, there's a reason this is the standard for so many public APIs. It's just so easy to work with. It's all about resources, it uses JSON, which we can all read, and that simple request-response model, it just works everywhere. That makes it a dream to debug and integrate. But then you have the other side of the coin, gRPC. This thing was built for one purpose, high-speed internal communication. It's not about resources. It feels more like you're just calling a function on a totally different service. And instead of text-based JSON, it uses super efficient binary data formats and can handle really powerful streaming patterns. And this slide just nails the core trade-off you have to make. With REST, you're getting maximum compatibility. It works in browsers, caching is easy, it's the safe, universal choice. With gRPC, you're trading that for raw speed, tiny payloads, and really strict type-safe contracts that can save you from a world of integration pain. So the question for you is, what do you value more, compatibility or performance? Okay, now for a security decision that, let's be honest, every single developer has to grapple with. A user logs in, great, but now what? How do you remember who they are for the next request and the one after that?
So the classic way of doing this is with session-based authentication. The server creates a unique session, stores it, and then hands the client a little cookie with a session ID. The key concept here is that the state, who the user is, lives on the server, and that makes it super simple to say kick a user out. You just delete their session on your end, done.
Then there's the more modern way, using JSON Web Tokens, or JWTs. In this model, the server creates this self-contained, digitally signed token that has all the user data inside it. The client holds onto this token and just sends it with every request. And here's the game changer. The server becomes stateless. Any one of your backend services can look at that token and validate the user without having to check some central database. This is huge for scaling modern distributed apps.
So the crucial trade-off really comes down to this. Session-based is stateful. That makes it really easy to manage and revoke sessions, but it can be a headache to scale. JWT-based, on the other hand, is stateless. It scales like a dream, but revoking a specific token before it expires? Yeah, that's a much trickier problem to solve.
All right, we've designed our system at a high level, but how do we actually build it, manage it, and most importantly, debug it when things inevitably go wrong? Let's zoom way in, from architecture down to the essential command line tools that you're going to be using every single day.
Okay, so picture this. An alert just went off. PagerDuty is screaming at you. The first thing you do, you gotta get your bearings. These commands, ls, cd, they're not fancy, but they become pure muscle memory. They're how you navigate any Linux system to figure out what's going on. They are the absolute foundation of any incident response.
So now you're in the right log directory, and you're staring at a log file that's, I don't know, a few gigabytes. It's a massive haystack. How do you find that one tiny needle? This is where the power tools come in. grep, awk, sort, these are your best friends. They let you slice and dice that noise, turning millions of lines of text into the one single error message that tells you what's broken.
Hi, the logs are pointing you to one specific server that's acting up. So what do? You use these tools. These are your eyes and ears on that live system. SSH is how you get in the door. And once you're in, PS and top are like your EKG, telling you exactly what that machine is doing right now. You just can't debug a live production issue without them.
So we've covered the tools for the systems we build today. For our last piece, let's look a little bit into the future. Let's talk about a tool that's designed to connect our systems to the world of AI.
This is called the Model Context Protocol, or MCP. And seriously, just think of it as a universal translator for AI models. It's this open standard from Anthropic that lets models like Claude connect to all kinds of external tools. We're talking databases, APIs, file systems, you name it, and it does it without you having to write a bunch of custom glue code for every single integration.
And the architecture is actually pretty simple, which is what makes it so powerful. You've got the host, which is the AI app itself, like Claude. Then there's a client inside the AI model that knows how to format requests. And finally, you have the server, which is the bridge to the outside world. It's just a clean, standard way to give AI real-world superpowers without reinventing the wheel every single time.
And there you have it. Your decision toolkit is now officially upgraded. I mean, think about the journey we just took. We went from the very front door of your system with API gateways, to how services talk with gRPC, to how we keep users secure with JWTs, and all the way down to the command line tools and AI integrations that make it all work.
So I want to leave you with one final thought, something to bring all this high-level theory back down to earth. When the alerts are firing, the pressure is on, and the system is down, which one of those Linux commands do you find yourself reaching for over and over again? It's a simple question, but the answer says a lot about what it really means to be an engineer in the trenches.